Welcome to the Yaka Digital Network. Let's start with a familiar scene. A crisp morning here in Uganda, and a student is riding a bicycle down a red dirt road on their way to school. As they pedal, they hear a harsh, rhythmic squeaking noise coming from the chain. That sound is metal grinding against metal. It is a clear sign of friction, warning that the chain is quickly wearing down. Instead of waiting for the chain to snap, the rider stops, pulls out a small can, and applies a few drops of oil. Instantly, the squeaking stops, and the pedals turn smoothly again. That simple act, solving a problem before it actually breaks the equipment, is the foundational rule for taking care of any mechanical device. This chart breaks equipment care down into two distinct paths. On the left, preventive maintenance means taking routine actions like cleaning and lubricating before failure happens to keep the machine healthy. On the right, corrective maintenance means ignoring the squeaky chain, forcing emergency repairs, or replacing parts because the machine broke down. Waiting for a machine to break costs you money for new parts and wastes valuable time. Taking care of your equipment along the way is the only reliable method to make sure it lasts. If we step into a standard school workshop, we see dozens of strong metal tools, but even thick steel degrades over time. There are three invisible physical forces constantly attacking these tools, even when they sit on the shelf. First, looking at this close-up diagram, we see the effects of friction and wear. When dry metal parts rub against each other, they act like sandpaper. Tiny particles of material are scraped away. Eventually, the parts become loose, sloppy, and inaccurate. The second threat is corrosion. When moisture from the air or human hands settles on bare iron, a chemical reaction occurs. The surface turns into brittle reddish-brown rust, which literally eats away the strength of the metal. The third threat is fatigue. Notice how this diagram shows vibrations traveling through a handle. The constant stress from hitting or shaking creates tiny microscopic fractures deep inside the material. Over time, those fractures connect, and the part snaps without warning. Friction, corrosion, and fatigue are entirely natural processes. Once we know how they attack our tools, we can fight back effectively. We defend our tools using 4 daily habits. Step 1 is simple cleaning. Wiping away dust and dirt removes the grit that causes friction before it ever has a chance to scratch the metal. Step 2 is lubrication. Applying a thin coat of oil or grease stops friction and blocks moisture from causing rust. But there is a catch. If you apply too much oil, it acts like sticky tape. It will attract dirt and grime, which actually damages the machine faster. Step 3 is tighten and adjustment. Because normal use causes machines to vibrate, screws and bolts naturally wiggle loose. We must regularly secure them, applying just enough force so they hold tight without grinding down the metal grooves that keep them locked in place. Step 4 is inspection. This means actively looking for hairline cracks and listening closely. A sudden grinding or clicking sound is usually a machine's way of crying out for oil before a part snaps from fatigue. Cleaning, lubricating, tightening, and inspecting. When done regularly, these 4 steps neutralize the physical forces that try to ruin our equipment. Before we ever touch a tool to maintain it, we have to talk about safety. If a machine uses electricity, your absolute first step is to completely disconnect its power source. To prevent accidents, we use a safety system where we disconnect the plug and attach a bright red warning tag. This is often called lockout-tagout, and it guarantees that no one else can accidentally turn the machine on while your hands are busy working on it. The entire purpose of maintenance is to keep the operator safe. Physically disconnecting the power is the only fail-proof way to prevent serious injuries. In a busy school workshop, doing the maintenance is only half the job. If you do not write down what you did, it is incredibly easy for the next person to forget to oil a machine for months. This is where a maintenance logbook comes in. By checking this ledger, a student can see exactly when a specific tool was last cleaned, who lubricated it, and what repairs were made. It creates a clear history for every item in the room. Even the way we put tools to bed matters. Placing a tool back into a dry rack or a locked cabinet keeps it away from damp floors and protects it from being dropped or misused by someone else. A well-kept workshop runs on a daily habit of organization and care. These simple routines ensure every tool is ready for the next class. Let's test your skills. Imagine you are the workshop monitor today. You walk in and find a metal hacksaw. The frame is covered in rust, and when you pick it up, the handle feels dangerously loose. Based on everything we've covered, what specific steps would you take to make this tool safe to use again? Pause the video here and write down your action plan. Let's check your answers. First, you should clean off the rust using a brush. Next, apply a very thin coat of oil to the metal to stop corrosion from returning. Then, tighten the loose handle so it does not wobble during a cut. Finally, you must record your work in the maintenance logbook. Whether it's a bicycle on a dirt road or a saw in a workshop, a small amount of daily effort keeps simple machines safe, efficient, and ready to work for years to come. Thank you for learning with the Yaka Digital Network. For more interactive lessons, practical challenges, and complete courses, visit our website today.